So as we discuss the concept of limit, now we'll talk about the neighborhood point. Okay, most of the students, they are not aware with this. They know what to do in limit because they remember the formula, but they don't know actually what we are doing there. Okay, what is the concept of limit? Previously just explained that on a number line, so if I have number at any value of x is equal to a, I'm trying to approach from left and from right. This concept probably would have known to some of the student, but the point here is how to approach this point. Some guys know left hand limit and right hand limit are equal, but we don't have to do like that only. See, neighborhood point means at this we are not, since we are not approaching x, or we are not making equal to x but only approaching x, it means we have to take some neighborhood point here, like very near to this a. So, and that should be same, like both side I'm taking the very, so that's why if I'm taking very small parameter delta. Okay, so let a be is a real number and delta be a positive real number. I'm taking a positive, it will be always positive real number. Then the set of all real numbers lying between a minus delta and a plus delta are called as neighborhood point. It means if I'm taking, it is not like that you have to take always delta when you are doing to when we are going to solve the problem. So most probably I'm gonna take the value as h, so you can take h, that's not a problem. My concept here is we have to take only one small positive number. Okay, so delta I'm taking very small positive which is very nearhood of basically you can say that a. So delta is my positive value, so we can say that the points between a minus delta and a plus delta are called as neighborhood point of a of the radius delta, and it is denoted by n of delta. These are the number of points basically you can say that. Okay, so thus we can say that the n of delta a is equal to nothing but, we represented this in terms of a set. Okay, set builder form basically, if you are aware with that, set builder form. So where my a minus delta and a plus delta are neighborhood point, in between whatever the point, it can be any point. Okay, where x is belongs to r and this. Okay, now this set a minus delta and a is called as the left neighborhood point. It means this is my a point and here will be somewhere a minus delta point. We can say that left neighborhood point, and right neighborhood point will be nothing but a plus delta and a. Okay, so these are right side neighborhood point. Okay, so we have to work out with these sets of the neighborhood point to find out my limit exists or not for a particular function. Again, I'm telling you, don't get confused with the lambda. In case if you're not, if you're having some confusion with lambda, you can take this as h. The main concept is this h should be a positive real number. Okay, and very small quantity. You cannot take this as 2, 3, 4, 5 something like that. Very small quantity, so that we can say that it is in the neighborhood, because if it is small then only neighborhood. Okay, you cannot say that you are sitting somewhere place and your friend is sitting in a 3 or 4th row something. You cannot say neighborhood. Neighborhood means the next row or next column it be. Okay, that's why this h should be very less. Okay, but positive number. Clear? So let's talk about the existence of limit. Since we already know about the concept of neighborhood points, again I'm gonna tell you, very small positive value near to a. Okay, so what is the meaning of existence of a limit for a function? If I have function f of x and I want to check the limit for this function at particular x is equal to a at some point, so I will say that limit x tends to a negative f of x is equal to limit x tends to a positive f of x should be equal for that limit to exist. Okay, or else we can say that left hand limit must be equal to right hand limit. Very, very important. If limit doesn't exist means you cannot talk about the continuity and differentiability at all. So you should check the limit exists or not, or this limit is exists, then we can proceed further for continuity and differentiability. So again I'm gonna tell you, we have two limits, left hand limit and right hand limit. So it can be, you can say that the x tends to a, if left hand limit is L, so right hand limit should be L only. Okay, and if I'm taking this as L and this as L dash, so my L and L dash should be equal for this limit to be exist. Okay.